MVC is an acronym for Model View Controller. Here's why it's called like that. When a request occurs, the URL is not mapped to a page. Instead, it is mapped to the method of a class. This class is called the controller, and the method is called the action. With the default routing, the URL product/index will map to a controller named product controller with an action called index. The action will then do the processing work. It will typically retrieve the data first. That data is then put into a model object which is meant for the view to consume. The view will then use the model to render the data. A POST request works in the same way, and data binding is also supported. The data binding typically occurs against a parameter of the method. Program CS looks the same as with the Razor Pages project. The only difference is that we now add the types needed for controllers with views to the dependency injection container. And we call map controller route, which will define the routing rules, the way the URL is mapped to controllers. That means that the URL product/index will trigger the index action in the product controller. If there's no controller specified in the URL, it will assume the product controller has to be used. And when there's no action specified, it assumes index. When I start the project, just the domain part of the URL is used. There's no pattern for a controller or an action, so the default is used. When we add /product, the controller is mentioned, but the action is still omitted. But the default action is index. And of course we can also use /product/index. That fully matches the controller action pattern for the same result. Returning to the structure of the project. There are other folders now that correspond to the letters MVC. We have models, views and controllers. The product controller is the workhorse. The product repository is injected. And the index action returns an iAction result. First, the data for the view contained in the model is fetched, and then we return an action result called view, which will instruct MVC to render the view for this action. And we pass in the model. When returning view like this, MVC will look for the view itself. It will check if there's a views folder that contains a folder with the same name as the controller class, without the controller suffix. In that folder it will look for a view with the same name as the action. Here it is. Again, it is just a partial markup for this view. And that's because MVC also features layout pages. Notice there is no line add page. That is only used for Razor Pages. The model is defined, and the model can be any type you want. Since we just need a list of products in this view, we make it an IEnumerable of product. Of course, the object passed into the call to view in the controller must match the type defined in the view. In the view, the list of products is again rendered with the for each statement. But this time we can iterate through model directly because it's an IEnumerable of product. In the final div, there's the A tag again, but this time the ASP action tag helper is used, which points to an action in the same controller. In this case, create. Let's look for a create action in the product controller. Here it is. It is just returning the view. And the view contains the form. When the form is posted, the other create action is triggered. The HTTP post attribute specifies that this action should only be executed when a post request is received. In our case, that means when the form is posted. The action accepts a product as a parameter. And here's where the data binding magic happens. Now that we know Razor Pages and MVC, let's compare them. So which one should you choose, MVC or Razor Pages? As always, it depends on your personal taste or your team preference, and on the type of project you are working on. Here are some considerations. MVC is more complex than Razor Pages. Working with 3 moving parts in MVC is harder than just working with one. In Razor Pages, model, view and controller are basically one thing. Routing is also more complex in MVC. With Razor Pages, it is straightforward. A URL matches with the page. In MVC, there's a routing table that maps to actions in controllers. The separation of controller, model and view could also be an advantage. When there are developers just writing HTML and CSS, for example, where other developers create the logic behind it. On the other hand, changing one page, for example adding an input element, would require changing 3 separate files in MVC, which are all in separate folders. In Razor Pages, that change would be easier. Because everything is integrated in Razor Pages, reusability is more difficult. In MVC, it's easy to reuse a view, for example, by just returning it in multiple actions, even across different controllers. Hopefully, this will make choosing more easy for you. But if you can't choose, then using them together is also an option. Since they both use the same ASP.NET Core motor under the hood, they can be integrated into one project. Curious about client-rendered front-end applications? Continue on to the next module. Client-rendered applications utilize the processing capabilities of the browser more than server-rendered applications. Blazor is the technique to use when you want to create client-rendered applications with ASP.NET Core. And there are 2 approaches to writing Blazor, using Blazor WebAssembly or Blazor Server. But first, what is a client-rendered application? When a user first accesses the URL of a client-rendered application, the request is handled by the server. The server will send back all front-end assets, such as unrendered Razor, plus the logic surrounding the user interface. That means that the browser will get all pages of the application at the same time, plus the logic to navigate through them and to populate them with data. Because it gets everything in one go, client-rendered applications fall into the category of single-page applications, or SPAs in short. As soon as everything is received, the browser logic will look at the URL and determine which page has to be displayed, after which it will render it and show it. When there's a redirect to carvedsrock.com/about, for example, this redirect will be handled by the browser itself, not by a server. The internal browser router again will determine what it has to render and display that. But what if data from a data store has to be accessed? The Carved Rock index page, for example, will need the list of products. In that case, the browser will reach out to the server again. It doesn't have to get HTML or anything else that has to do with the user interface, because that is already present in the browser. It just needs the data. So the server will return just that, and the browser will apply it to the page. This server doesn't have to be the same one as where the assets came from, as long as it runs a backend application called an API. The demo application in this module doesn't use APIs yet, just the in-memory data we saw before, but that will change in the next module. We're exploring Blazor WebAssembly next. Blazor is the way to create client-rendered applications using components in ASP.NET Core. Components in Blazor are written in Razor and C#. A page is a component, but pages can also contain non-page child components that can be reused. For example, here are 2 pages. The index page uses a component to subscribe to a newsletter. The About page component also uses it in a different location on the page. One of the main advantages of using a component like this is that we only have to implement the UI and logic around, in this case, subscribing to newsletters once, and it can be reused over and over again. But let's take a little step back. Maybe you still have a burning question like, but browsers don't understand C#, so how does this work? Here's the slide again that shows the initial request to the server. The server has the user interface in the form of components written using Razor and C#. These components are sent to the browser in assemblies together with the .NET runtime that can render the components. The browser can use the runtime because it is compiled into WebAssembly, a language the browser can understand, just like JavaScript. WebAssembly, however, is a lower level language in a binary format. It is not something you write, it is something you compile your code to, just like C# code is compiled to intermediate language in .NET assemblies. Speaking of that, when the runtime executes in the browser, it will be able to process the IL in the component assembly. It will execute all code present in the components and render the Razor to HTML. Here's the carved rock application done with Blazor WebAssembly. At first glance, it looks like a Razor Pages project, but there are some significant differences. The code in Program CS is different, for example. Because this code executes in the browser, we use a special WebAssembly host builder to get our builder object, after which the root component, the starting point of the application, is specified. And that's a component simply called app that comes with a template you get when you create a new WebAssembly project in Visual Studio. Each component is translated into a class in Blazor. That's why it can be referenced like this here. The app component renders in an HTML element with the ID app. But where is the HTML? It is in the www root folder. And it isn't Razor, just plain HTML, and indeed the element with the ID app is here. Another thing that stands out is the loading of a Blazor JavaScript file. This JavaScript file takes care of loading the runtime and initializing the application. Let's see what is in app.razor. Files that contain Razor have a Razor extension in Blazor. This app component contains a router component. Blazor components can be rendered using the same tag syntax we use with HTML elements. The attributes used on the component are actually properties in the class behind the component. Router is a Blazor built-in component, and the reference to the current assembly is passed in. The router component will now scan the assembly for page components with routing information that matches the current URL. If a component can be found, the route view component takes care of rendering the component with a layout page called main layout. Let's take a closer look at Blazor components.